Okay, so we did split the object into 5 pieces, and we did find out where the center of mass location for the tabletop is for that piece. And the next thing is again multiplying the weight force of that tabletop with the center of mass location. So when you do 20 times 0.75, you get a 15 inch-pound. And we will do the rest of it as well for the legs. And if you understand one of the legs, again, the rest is the same. But understanding this quantity may not be that straightforward. So maybe take it, like, pause the video and then try to get that value your own first. Okay, try it, and if you can get that. And then come back here and then kind of check if you get it the right way, or you can see how to get it. So the leg is 2.5 feet long, right? So that's the length of the leg, as you can see it on the figure. So the marked point that I have is half of that. First of all, that 2.5 feet, since we also have like some inch values, so we need to be consistent. 2.5 feet is 30 inches. And then the marked point from the top of the leg, not from the origin, from the top of the leg. So if you want to write down how much this is going to be 15 inches, right? However, this is not x2. That's not for the one of the leg from the center, from the origin. You have also this 1.5 inches. So you got to write from here to all the way down there. Okay, so you have to add that thickness of the table as well. So what is z2 then? 1.5 inch plus 15 inches. And that's going to be true for all of them. So the leg height, half of the height is going to be center of mass, but you're measuring it from all the way from the top. So that becomes 16.5 inches. Okay, so that 1.5 needs to be added because the origin is at the top of the table, not at the bottom of the tabletop. So that's very important. Again, the where the origin is really changes everything. So you have to make sure you understand where it is. And again, next is the leg has 3 pounds weight, and that's the center of mass for the leg. You multiply those two to get Wi, Zi, this becomes W2, Z2. And that's what you have. And you can see that the rest 4 of them are the same as because of the symmetry, and they have the same mass. So the last thing you do, you add up all of them. So this becomes the sum of Wi, Zi, which goes onto the top of the equation, as you can see it here. And we also have the weight force, that's the total weight force. So you have everything to solve for Z center of mass. So all we do is, again, here, plug those numbers in and solve for Z center of mass. So that is 6.66 inches down from the top, and it makes sense that is that high because the tabletop is much heavier, right? But estimations were correct. We thought that would be less than 1 feet. It is a little bit more than half of a feet, but we did consider that it would be high. And so the z-coordinate of the center of mass, I'm having difficulty with the technology. The z-coordinate of the center of mass was found to be near the top of the table, as expected. And we use the same solution approach as the previous problem. And if thrown, the table's center of mass traces a parabola. But we probably won't throw the tables, right? We will find smaller objects to throw. Okay, the next is now the second law. So, okay, we understand how to find the center of mass of an object, I hope, by now. And that's going to be the initial step. Okay, if it is not obvious, if it's not the object is not simple, then again, you split up the pieces that are simple, symmetric, you know the geometry well, and then you can find the center of masses easily. And again, making a table helps. That's what we've been discussing in the examples. And next step is, once you find that point, once you locate the center of mass point, how do we understand the motion of that object? it's really what we've been doing so far. This is really just extra step. Get that center of mass point. Just use what you've been using before. So let's clarify a couple things here. So for an irregular shaped object, Newton's second law, or Newton's laws, still works, but it applies only to the center of mass. Okay, so the second law, the acceleration, we can only know the center of mass points of acceleration. And then when you know the forces acting on the object and the mass of the entire object, you can still use second law. Okay, so if you look at the equation sheet, there are a bunch of equations like that. This is the entire the vector equation. F and A are bolded, they are the vectors, and then you can write them in component form, so you also have those. Again, there's more labeling, so that might be a little intimidating, but nothing different. So this is not a new equation. So the vectors are scalar, as we know, but they have, we need to keep the signs. So the again, important things are m is the total mass, and a is the center of mass acceleration only. You cannot arbitrarily choose a point on the object. And then you can write that for the three components and x, y, and z, like that. So if we have an irregular object like that, we can find the center of mass points, we can find center of mass accelerations, and then we can still apply our second law this way. Okay, yeah, but this is nothing new, so don't think that this is new. Next is an activity, and I want you to really read this before getting to the quiz problems. There were a couple of quiz questions in the beginning, but now there's more coming after this. So, and I will also show you the video, and I will do that in the next video.